show that for a given flat belt drive, the power transmitted is given by P is equals to T1 minus T2 over U E mu theta close the brackets V or P is equals to T1 over the brackets 1 minus 1 over E mu theta close the brackets, where P is equal to the power transmitted by the belt, T1 is equal to tension in the tight side, T2 is equal to tension in the slack side, V is equal to the velocity of the belt, and theta is equal to the angle of lap, and mu is equal to the coefficient of friction. Now, considering this diagram, we have on the top side we have the T2, which is the tension in newtons in the slack side, and then at the bottom we have the T1, which is the T1, which is the tension at the tight side of the belt, which is in newton. Tension T1 is the tension at the tight side at the tight side, which is also in newtons. Now we have an arc subtended by the belt at AB. The arc subtended at the belt AB. Now that is a portion of the belt which is in contact with the. That is now the portion of the belt that is in contact with the pulley. Now that portion subtends an angle theta at the center of the pulley. That the angle at the center of the pulley home is theta. Now we have frictional force F. Now frictional force F is the friction between the belt and the pulley. The friction between the belt and the pulley, which is F. Now we have the normal reaction force Rn. Now taking this small portion P, Q and O, and we magnify it and have this diagram. Now the small portion of the angle, the small portion PQO of the angle at the angle at the center of the pulley, it's now being divided. When we magnify this portion, we divide it by 2, and it becomes alpha theta divided by 2. This angle is equal to this angle is equal to this angle, and is equals also to this angle. Now, resolving all the forces horizontally. All the forces horizontally, we are going to take Rn. Now, all the forces horizontally, all the forces horizontally, we want to take Rn. Now, we know that sine theta is equals to opposite divided by hypotenuse. Now, sine theta, we are now going to take this angle at this part, which now becomes alpha, theta divided by 2 is equals to, now our opposite is not this force, which is R, this force which is Rn. Now opposite, which is now Rn, divided by hypotenuse, which is the tension at the slack side, which is now the tension at the slack side. Now that becomes sine alpha theta divided by 2 times t is equals to Rn. Now Rn is equals to sine alpha theta divided by 2 t. Now that is for the slack side. Now let's go for the tight side. This part, that was for the slack side. Now let's go for the tight side. The tight side is now t plus alpha t. Now for the tight side, we want to have sine alpha theta divided by 2 is equals to, our opposite is Rn. Hypotenuse is the tension at the tight side, which is t, plus alpha t. Now this one is sine alpha theta divided by 2 in alpha divided by 2 t plus alpha t is equals to Rn. Let's now combine this Rn and that Rn. Now Rn is equals to sine alpha theta divided by 2 t plus alpha t plus this one sine alpha theta 2 t. Now because this angle alpha theta, this angle is very small. Because it's very small, we are going to replace it with sine alpha theta divided by 2. We are now going to replace it with alpha theta 2. Where we have sine alpha theta divided by 2, we replace with alpha theta divided by 2. Now Rn is equals to, we replace this one, t plus that one, the same here. We replace this one with this t. Now when we open the brackets, alpha theta t divided by 2 plus alpha theta alpha t divided by 2 plus alpha theta t divided by 2. Now this is also very small. Now let's now neglect it. Rn goes to alpha theta divided by 2 plus alpha theta divided by 2. Now our LCM is 2. Our LCM is 2. Now we to have alpha theta t plus alpha theta t. Now our Rn becomes 2, because they are 2, alpha theta divided by 2. Now which is the same as alpha theta t. Now this is now our equation 1. So Rn is not, this Rn is alpha theta t. This is our equation 1. Now let's now resolve all the forces. Now let's resolve all the forces vertically. Now all the forces vertically, we are going to consider frictional force F, which is mu times Rn. Now because it is vertically, now we are going to consider we are going to use cos. We know that cos is equals to adjacent over hypotenuse. Now cos this angle, which is cos alpha, now cos alpha theta divided by 2, cos alpha theta divided by 2 is equals to adjacent. Now our adjacent is URN, our adjacent, which is URN, then hypotenuse is the tension at the right side. Now cos alpha theta divided by 2 times t is equals to URN. Now this is for the slack side. Now let's go for the right side, this part. Now cos alpha theta divided by 2 is equals to URN. Now for the right side, t plus alpha t. Now here we are going to have cos theta divided by 2 t plus alpha t is equals to URN. n. Now let's combine this one with this one. U r n is equals to cos alpha theta divided by 2 t plus alpha t. Because now it's vertical, we're going to minus cos alpha theta divided by 2 t. Now this angle is very small. Cos alpha theta divided by 2, that angle is very small. Now we're going to replace it with 1. We are going to replace it with 1. So cos alpha theta divided by 2, we are going to replace it with 1. Wherever we have this part, we replace it with 1. Now u r n is equals to, here we replace 1 t plus alpha t minus, here we replace 1 t. Now u r n, now this one and this one becomes alpha t. Now divided by u divided by u. Now r n equals to alpha t u, equation 2. Now we have equation 2 and we have equation 1 and we have equation 2. Now let's equate them. Now equation 1 is r n is equals to alpha theta t. Equation 2 is r n is equals to alpha t over mu. Now we have alpha t divided by mu is equals to alpha theta t. This one is the same as writing alpha t is equals to alpha, the same as alpha u theta. Now let's integrate this part. We want to integrate this from t2 to t1, and then we are going to integrate this from 0 to theta. Now we are going to introduce log e t1 minus t2 equals to u mu theta. Now log e t1 t2 equals to mu theta, times theta. Now when we divide both by log e, when we integrate and divide both by log e, we're going to have t1 over t2 is equals to e mu theta. Now we know that power is equals to t1 minus t2 times speed or velocity. That is, we know that power is equal to this one. Now this equation can be written as t1 e mu theta is equals to t2. Now we replace t2 here. P is equals to t1 minus t1 over e mu theta cross the bracket v, or this one can be written as P, remove T outside, T1, open the brackets, 1 minus 1 divided by E raised to mu theta, close the brackets, V, close the brackets, V. Now we have proven that P is given by, we have shown that and proven that P is given by, open the brackets, T1 minus T1 over over E raised to mu theta, close the brackets, V, or power is equals to, or P is equals to T1, open the brackets, 1 minus 1 divided by E mu theta, close the brackets, V. Thank you for watching this video.